Okay, so what do you think would happen if we have two waves in a space? They have a very similar frequencies, so the frequency, difference in frequency is very, very slight. Okay, very slight difference. What do you think would happen? What kind of sound do you think you would hear? Well, there is something called the concept of beats. Beats. So when two sinusoidal wave of slightly different frequencies, let's say F1 and F2 here, they overlap, meaning superimposed to each other, then we'll see the superposition of the wave here, right? Then, okay, that sounds more mathematical. What does it really mean? Okay, that's the part, right? So two waves superimposes to one another, and then there is something called bits. You would hear something called bit. Okay, so two waves that are kind of overlapping to each other. So there are two things. I'm going to write this down here too. If frequency of oscillation that you hear is given by just the average of the frequency of those two waves, so that F oscillation is just half F1 plus F2, where F1 is the frequency of one wave and F2 is the frequency of oscillation of the another wave. Okay, so this here F oscillation is a pitch. Okay, this gives us a pitch. This gives pitch. Okay, so this pitch also means the note that you hear. Now you'll also hear when these two waves, they are traveling and then they have a slightly different frequency. You'll also hear something called F bit equal to, it's given by F1 minus F2, or it could be also F2 minus F1, depending upon whichever number is bigger. You basically take the positive value or the modulus of that, okay? Because this is really the difference in the number, and that is positive value. Negative frequency doesn't make sense, right? So this is there's something called F bit. So this bit is something like the difference you would hear, something like like a high, like loud, soft, that sound pattern you hear is bit frequency. I'll post it on handout, the link about bit frequency simulation, so you can kind of listen to it. Okay, so that's the bit frequency is the difference between the frequency of the waves when two of the waves of slightly different frequency traveling, and I mean overlapping with each other or superimposing with each other. Okay. So you may be wondering, okay, so what's the big deal about this bit, right? Well, there are several applications. So bit frequency, you will also use this concept when tuning up musical instrument. Another important example is Doppler shift. This one, so you guys already know about Doppler shift, right? When we were learning about the sound. But then here, do you guys know, like, when you speed up, basically, like, how do you think the cops find out, what's your speed of your car, right, vehicle? So what happens is, there is, so the radar detector, what does it do is, it sends the sound, okay, with certain frequency, let's say some F1, and then it hears back the sound that's reflected sound back, so it will have a different frequency, but then they are just going to be a little bit slightly different. So using this concept of bit, using this concept of a bit frequency, really Doppler shift here, then it can, the detector can calculate the speed of the target, moving target. Okay, so that's how the radar detector determines if you are speeding up or not speeding up. Okay, something very useful, right? Okay, so interference of waves from two sources. Um, what you hear, let's say you have, let us say, so let's say you have one speaker here, and then there is another speaker somewhere around here, and then you are standing somewhere over here. What do you think you hear? What does it depend on? So really, it has to do with something called interference of the wave, and then so what you hear here depends on where you are standing in the location of these speakers. Okay, so there is also simulation from FIT Colorado that you could look up about the interference of waves. Again, this link will be available in the class overhead. So please use this link to view the simulation. Sorry about that. Okay, so